Hello there. Good day. Today we are going to have a very, very short stream because later I'm um, going to celebrate New Year's Eve in some kind of new fancy way. Because I said, hey, I don't want to buy any stuff. Usually don't buy a lot of expensive stuff anyway. Burn it outside and then having to clean up all the the used fireworks that you have to clean up afterwards. And I just said, okay, I don't know what to do, just to avoid that, or to just buy some fireworks for just to pretend like I'm celebrating. But yeah, it would only be fun if it would be very big fireworks and like big rockets or something. That's stuff that I usually like to see. So it's the stuff that usually normal people can't really get. It's more of like town when the town organizes a city fest. They use these huge rockets and make a light show out of it. So yeah, I really never enjoyed that part. So this year I will celebrate in VR chat, and it's also my first time in VR chat. So later I'm going to end the stream in approximately an hour or so, and then yeah, go there, try that out, and pretty much I don't have any clue what's happening there, and I haven't been in VR chat really, just setting everything up. Okay, but that's off topic. Let's go to the topic. 1 hour. Let's use that hour. Okay, with 1 hour to try to do something about our slopes. So we had the character. He's standing still on slopes now. He was sliding down before. Now he's standing still, but we still have the problem that we can if we go down the slope, we are jumping, and if we go up, it will always finish with a jump, and we don't want that because people feel like that feels kind of weird that every time you go up a hill that you are jumping, because it kind of is what people expect after playing a lot of games. So we have need to fix that, and first of all, let's go. We need to, this is something that I will tell you about later. Nothing big. First we have to keep analyzing. Just a small flashback here. So we are standing on the slope. And when we go up, we see this small jump, and we go down, we also see the character is jumping. Can stand on the slope already. That's something that we fixed. But every time we will go down the slope here, character will jump. And we don't want the character to jump here. We want the character to actually stick to the ground. Yeah. And the first thing that I suggested here was that the character should kind of stick with the physics properties. Unfortunately, it seems that Unity just doesn't work that way, and since we are actually not using real physics, we will kind of really have to forgo the transform position, which is something that I really am not looking forward to do, because it's this means we really have to make this really good. Okay, so let's get going and see if you can open the script. So I was opening a script, and my free rider that is the editor for the code, has expired, and I'm just using Visual Studio now for today. I will get wider later, but yeah, it was basically get wider today or start streaming, and I was just like, hey, let's stream today. I'm not too much into getting every update of wider and giving the money just for one day. Actually, it's also better because tomorrow is the 1st of January, and yeah, then I can be sure that if I make an abonnement for a year, that it will actually be for the whole year, not just one day. It would be ridiculous if they would charge me a full year plan and then it's one day. That would be not good. So yeah, tomorrow may be the best time to make anniversary abonnements. So I'm here in Visual Studio, and what I want to do here is if I want to look at the character. Here's the player, and here's the script that controls the character movement. And here we can see it in Visual Studio. Visual Studio is not as fancy as wider, but has significantly better loading times. I didn't remember this. So it isn't bad after all. Or you can't attach it to Unity. You don't have all those fancy functions for debugging that come with wider. But that isn't that important. So what is the first step what we want to do here? Now we have this function over here. Let me try to find it. It was something with drawway here. Detect slope state. This is a function that is going to tell us if we are on a slope or not. And we ended the last stream when we were coding in this these lines of code here. And what these actually do, I actually can just show you because can test it out here. If you are standing here on this position, we now see this green line. So what does it do? It draws, it casts a ray up from here, from the middle, goes down here, up to this point, and then it will get the angle of the ground and cast a ray with its normal. So very complicated. Long story short, if we detect the angle of the ground underneath the main character. So first of all, we now draw this until infinity, and we now we want to change that here. Now this would even detect, we don't want to change that yet, but later we want to change that into a variable. Let's change it into a variable now. Float detection length, and this means we can maybe rename this later, and this is equal to a single positive infinity. So it will be infinitely infinitely, whatever. It will be long. So I think first I will just guess it. Detection length, and later I will guess this value, which is good. How and add a cap to this functionality, so we don't detect slopes that are too far apart from the character. If there might be cases where we are above a slope, but the slope is actually too far apart away, and we don't want to set the character to the ground immediately if there's slope way underneath him. Okay, so let's go on and say we cast 2D hit. So we have this waycast and save it up. And we only detect the ground. And now we were at the point where I was thinking, how do we detect the angle? And yeah, okay. And I was like, we have this hit normal, which is pointing into that direction as a vector, but how do we get the angle? And I was like, hey, isn't that just an angle? But I didn't find a function for an angle, and then I was like, hey, mathematically, you would just, if you would want to know this angle, you would have to add another way, vector 2, so you actually have an angle. Because you can't have an angle with just one vector. Actually, that's only an angle if you have something else there. So now you have an angle. Okay. Will Celtic Varia? Well, would you look at that? My favorite developer on Twitch with his smooth and calming voice. I love to listen to. Hey. Oh, I haven't enabled speech chat yet. I thought that I did. That's odd. Oh, connection failed. Okay, I think because of maybe New Year's Eve, I have to actually pay attention this time and read the chat messages by myself, which is I'm gonna do it with Chrome maybe. And oh no, come on, give me Chrome. Okay, Microsoft, you're trolling me. I wanted to open Chrome. You're googling Chrome with Bing. That's mean. That's mean. Kind of wants to bait me. So, yeah. Hello, real Celtic warrior. Hi, I hope you're doing well. Going fine on my part so far. Just had horrible holidays because I was pretty much just laying in my bed all the whole time, which is not nice. So now I have speech chat enabled. Unfortunately, speech chat doesn't work in Firefox today for some reason. Yeah. Sorry for seeing your message kind of late, but yeah, shit happens. Okay, let's go on. But yeah, I usually don't have comments at all for hours. Sometimes a whole stream, and that's why I usually don't pay attention to the chat at all. Just have a bot read it out and hope for the best that maybe speech chat works and will read the message so that I actually know that somebody is in the chat and asking me something. And every time speech chat fails, I absolutely have no chance. Because, game development, it's not tough, but you need a lot of focus. Okay, speaking of focus, let's go on. So what we need to find is an angle. Does this have an angle? Yes. We have this angle function. And I have to say Visual Studio is a little bit weird. We don't have any clue what this function does. So there's a catch with Visual Studio. Now I think something is off because normally Visual Studio should actually give me a hint what it does. For example, this overlap circle, and it should underline this. This should cause an error. Shouldn't compile. Or if I write it like this, yeah. So something is not set right. It's not Visual Studio. Something is not set up. Maybe it's first time starting Visual Studio. But I think I will have to manually go into Visual Studio and set up auto correction because something is off. Oh, there's something. You have to install something. Yeah, please do. And this is going to cost me another gigabyte of use. Okay. No, I hope it didn't save my it didn't do this without saving my code, even though I didn't even write anything except vector 2 angle. 1 gigabyte of code. What? What is it in 1.5 and 1.66 gigabyte of Visual Studio? Seriously. It's a coding program. How can it be so big? Does it have tutorial videos inside? It can't be just code. That would be very, very odd. Hmm. Would be super odd. So maybe they're installing every framework that exists or something. But I don't know why things nowadays take so much disk space. It's kind of raising some eyebrows for me, always. Like you would assume like that all that stuff is just a lot of code and they put in a lot of effort, but writing 1.67 gigabyte of code is nearly impossible. I don't even know if any project exists that has that amount of code which is really not generated but really handwritten code. And maybe I'm wrong, but also if this is code now, I think I really think if this would be code and this would be important code, 1 gigabyte of anything, something would be wrong with it. This is really core necessary code. So because if that's really core code, basically it would be impossible for any person to understand it. It would be humongous. So I'm going into my folder here. I want to see how much code did I write. And damn, I can't see it because I haven't sorted by, I did not sort by scripts. So I don't have all scripts in one folder. So I can't just go click and see how big is this folder, which is a little bit unfortunate. But it would have been a nice thing here. I could compare how much how many bytes of code I did write. Let's just see the biggest script here. Let's find the script. Platformer. And let's see. This is 119 kilobytes of code. Yeah, and then good luck getting anywhere close to 1 megabyte of hard disk space with writing code. It's, I don't know what they are doing there. Just something that I find kind of and the other script here, which is also maybe 100, 200 lines of code, 9 kilobytes. Yeah, and there's a lot of effort in these. So why am I saying it? It's just worrying me a lot that use this space for basically anything has been going up lately in really nearly exponential fashion. Now, I was really happy when SSDs really got to the range that they are 1 terabyte big, and basically you could back then big games would maybe have 8 gigabyte of disk space used, and that was really huge. And games today can use 100 gigabytes of hard disk space. Yeah, so you can basically fit let's say 8 games on a disk if you only have games on your disk now. It's kind of annoying because you essentially need 200 gigabytes for your system and just temporary data. I had a SSD disk with 64 gigabyte years ago, and it was just like, hey, I have only normal hard drives. SSDs were very new back then, but you can put your system on the SSD and it will boot up very quickly, and it would be great. And it was a wonderful experience, at least until temporary data just used it up in no time. It was like you did delete all that temporary data just from browsing the internet, and boom, you could delete the data, could maybe then use the PC for 2 months, and then do the whole cycle again. And it's kind of annoying that everything uses so much disk space that even with terabytes of disk space, you're running out of disk space regularly, and it's kind of annoying. And part of that is One part of that is actually very sad. It is okay. Couldn't open my script now. Let's try that again. Maybe it's just an updating error. Yeah. Oh, now we have this graph here, which isn't that bad. Oh, there's a region about here. But now it doesn't show me code lines anymore. So instead of lines of code, I get this image. Okay. So where was I coding? And it says the analysis of metadata data is deactivated because the project is too big. Okay, I will have to get wider again. So I can't work with this. So let's first search. Is the angle still in there now? That one. Yeah, there's a lot of angles. This was what I was writing. Okay, deleted that one. Draw way. Draw. Oh, that is. Okay. It's a little bit sloppy that it did not say what I was doing here, but whatever. The thing about disk space is things use so much disk space nowadays, which is often raising my eyebrow because it means it's all just pictures and videos and basically stuff that take up a lot of space. But good code doesn't need space at all. And a lot of programs don't seem to have anything that justifies having that much disk space. And this is really often a bad sign, where I just think, what are they doing? Why is nobody reviewing this as bad when things just take up enormous disk spaces for no reason at all? Where like, I often wonder what the hell they're doing. Why is this program just took 15166 additional gigs of space, and I don't know how much it already takes. It looks like it's small because we nowadays have terabytes of disk space, but it isn't. It's not small for what this program is supposed to do. Okay, now I have this angle function. I actually have some kind of guess what I have to put in here. I have to write big angle, angle uppercase, and I want to have the angle. I could. Okay, now I have to decide what kind of angle do I want to have. Do I want to have the angle from the way, the downwards way, and then the way that comes up here? Or do I want to look from a flat line? Because from a flat line, this is what is most understandable for us humans to work with. But I think having a down vector is maybe better. Yeah. Let's maybe vector. Let's vector up. Let's maybe stay positive. Um. And the hit normal. And let's just debug log this. Take the ground angle, angle, and I just want to. We could maybe. I've had an idea. Let's to see this while we're playing, and not just read it in the console. Just a little bit annoying. Let's just use the player health to visualize this. Now, unfortunately, our health can't be negative, so that's not good, but nonetheless, let's read out that angle. Okay, and we are ready to go. And this is basically all we will be able to do today. And then we'll have to finish the stream. So, okay, the health is not changing at all. It's 1. Okay, it's 1. And I died. Okay, let's just go here and look at what the console is writing. So we do have a lot of 45 degrees angles. Now it's a little dumb that we die if we detect an angle of 0. Kind of an interesting game mechanic there. But to keep that in mind, maybe it's going to become the next generation game. When the angle underneath you, under you is 0, you die. It's a good teaching game. So here it is not exactly 0. That is why our health is 1. And now it's 45. Oh, sine. It's. Yeah, I think I didn't want to use sine. It's correct. But here we have 45, 43, 0. Okay, interesting. It's really the most interesting game mechanic that I've ever seen. It's maybe the best game ever made. Best game ever made. So yeah, pretty much. So I didn't want to use sine. What did I want to use? Mm. 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 So it's always positive. Come on, that's really easy. Come on, that's really easy. I really know this one. It's so easy. um, apps, of course. Oh, hello. Thank you for following. And I just get Dino0040. Thank you for following. And I get an Illuminati triangle. Okay, interesting. So the Illuminati, they are with us. Have to be careful. They're watching us. So I'm just trying to get an angle. And what am I doing wrong? It's expecting a float. What does it get? Destruct. No. Angle returns a float, okay? And apps is also expecting a float. What's wrong here? Don't understand. Math is the unity one. Yeah, that doesn't matter. I was thinking about which one is the one which is always returning the positive number, and I usually know this one, and I just have a blackout today. Man. It's apps. It's absolute. So mathf is the unity one. Yes, I know. So mathf absolute, which is basically the same thing, is also returning can't cast from float into integer. And I just googled apps is actually the right function, so and this is returning a float. So what the fuck? No, I'm not really sure what's going on here. Health is an int, yeah. Oh yes. Yeah. Okay. Yes. Oh damn. Yeah, I've forgotten. Yes, health is an int. So I have to cast this into an integer, yeah. So basically I just want to, and I would never want to have this to be 0. So I will just say +1. Just keep that in my head. It's because if it's 0, so then we will die. I just want to have an easy method here to read out the angle underneath the character. So if I hit play here, to tell if Big Secret program bothers you. Actually, no one ever did that. Actually, you're basically the first one whoever did backseat programming here, normally people just watch a little bit and let me do my stuff, and yeah, haven't received many tips so far. It could also be because most of the time I'm doing more complicated stuff than this. But now you can see in the health bar, and this is the angle underneath us. So, and this is useful to detect if we are on a slope or not. So we are still in the testing phase, but you can basically already guess if we are on a slope just by seeing, hey, it's around 45 degrees. Yes, you can continue, but you have to keep in mind today is New Year's Eve. I'm not going. I'm doing half an hour, so it's not going to be long today. So, okay, now we have detected. I can also maybe tell you about the problem that we are going to solve. Two angles already unsigned. Yeah, that's correct. Yeah. At least it says so, so I don't have to just actually say math apps. Yeah, I was a little bit wasteful. So, okay, now we have the angle. We have the angle. Now what? Now we need to detect when we want to stick to the slope. So the problem remains now. We go up slopes, we jump. We go down slopes, we jump. Standing still on slopes is already done because we can detect slopes, but the old detection doesn't use angles, which is also a little bit annoying. It's also always better to just use the same system. So here we jump and here we jump. So now we need to detect the first frame where we go into the idle animation are not where we are in the air. Let's say the first frame, let's just pretend this is just one frame. Now we are in the air. Actually, it would be more like if this would be the first frame, let's be a little bit more realistic. It would be somewhere like here. Here, we left the ground. We are in the air, and the character will now go into its idle jump animation. But we don't want that. We want to now detect, okay, we just have been on not a slope. Or is that the part? Is it important where we are, where we come from? Just important that we were grounded, I think. So if we were grounded, if we were on the ground, touching the ground with anything, and then detect that we are in the air suddenly, and we haven't jumped, we have been pushed by an enemy or by a projectile, then we want the code to, first we just want to realize this. This is the first part. Yeah, we now have the angle underneath us. And the final part is where we just put him back down there. But we are not doing that today. I don't think we will do that in half an hour. Now what? We are in the air. So we were grounded. We are not grounded now. We can check for that because it's we have frames. It could actually be a good idea. And then we have to detect, is there something underneath us? We have the distance. Oh, there's something. Oh, no. Okay, that's okay. We have the distance and the angle. So if we are here, if we are above something and this is 0 degrees, then we should always fall. Because that means that we just had something very flat and it goes straight down here. So, and then we have to define a variable where we can put in the two variables where we can put in the minimum and maximum angle where we want the this function to apply, to put us down. Because maybe we're detecting later in instances where we just don't have slope but ground like this. This is the bigger challenge. Here we have to kind of detect how to do the same thing but with a lot more angles. So let's go. Okay, we are still in the hardware. Why does it suggest me am grounded? Did it listen to my speech? What the hell? Why? Why does it suggest me if I'm grounded? I don't get it. Especially as it's impossible. Now we already have a boolean that tells me if we are grounded or not. And it will change according to if we were grounded before, according to if we are detecting there's ground under us or not. But that's from a different function, so we don't see that. So maybe it's what? Yeah, it's impossible. Yeah, if not ground. Yeah, I don't know. That's really weird that it's suggesting me this. That is a little bit scary. I hope Microsoft is not listening to my voice right now. But if it is, hey Microsoft, tell Bill Gates he can send me a lot of money. All that taking up space by Visual Studio, and we get those suggestions. Yeah, pretty much. I bet Cortana has access to my headset right now. Okay, it's getting distracted again. Actually, later we will have to write if no, it's if was grounded. There will be a boolean, and we have to define that outside of this function. That will be like this: was grounded, and we will then check this is this true or not. And this is will basically just the state of grounded in the last state. Will just be the state of grounded in the last frame. We'll need that later. So obviously no. We can define it now. Let's put it up there. Somewhere in this mess. It's maybe the worst thing that I've ever done to humanity. I don't think that there's any way to sort this anymore. Ah, there's grounded. So I think M was grounded could belong here, and ignore that the naming convention is completely ignored. Ignore that, please. So first, let's write at the end M was grounded is going to be M grounded. And actually we have to do this outside of the if clause so that this will not be ignored. So if we are not grounded, we are in the air and we detect if grounded and but we was grounded. Yeah, we were grounded and suddenly we are not. We are in the air. Okay, first part done. Easy. We have we have we don't have the float for the so there will be one float for the detection layer. I have to rename this. Slope detection length, because we are going to use this later as a public variable. No, serialized field on the character, so we can put in some values and adjust those when we find out, hey, it's feeling a little bit weird, or the character is suddenly detecting the wrong slopes. Then we have two more floats. Float slope min angle, and of course float max angle. Slope max angle. I got a new keyboard. Still have to get used to that one. And let's just put in some random values here. Like, okay, I want this to be positive infinity for testing so far. And the minimum angle, I don't know, let's just say 40 to 50 degrees, and it's a slope. And later we might detect, hey, we don't want to go more than 50 or something. But I think that's for the first case, it's a good start. And then we just put in these floats. And slope min angle, max angle. We have to somehow use those. So then we say if the angle is between those values. So is there an intelligent way to write this? I don't know. So normally I would say slope min angle is smaller, and the let's save that into a variable. We don't need to do this twice, and this is a little bit easier to read. And slope angle is smaller than the slope max angle. Then we do want to do stuff, and we want to put the character down, and then we are basically done. So that's the whole code. Okay, yeah. Was a little bit easy, a little bit too easy actually. And yeah, these three will be serialized, so we can just later not go into the code again and just put in different values that we will kind of feel. So now to the part where we put the character down. Now we have already written the slope detection completely. I'm a little bit surprised that we didn't forget anything. I bet I bet it's not finished yet. I bet there will be some kind of issue. But let's just see what happens now. We are at this point, and now we detect false. Nothing happens. Easy. The algorithm says false. Okay, there's no slope where you need to be put down. Okay, and then nothing happens. The character will just fly. This comes if you are flying down like this part. This is where you're not supposed to be sucked down to the next slope or place. If there's an angle, slope somewhere here, you should not just fly down here. It should continue to jump just normally. Okay, now here's the thing. Oh, there were two more things. And then we have one thing. If we have jumped, if we have just jumped, return. Just never do anything. Then our slope state will be not on a slope. If a slope state will tell us where we are, and essentially then we can decide what to do. But now I have to continue here. Because if you just jump, or pushed. Yeah? If we are pushed by an enemy, by a fireball or something, then we want to completely lose control and let the character just fly over the slopes or anything. Because it's really, if you try to do this with the slope detection and stay on a slope, it's going to be really, really hard with a lot of exceptions. Like, yeah, the character is would try to go into the other direction. So you have the force in there, and you might be pushed up or down. So if you're pushed, let's just leave it to Unity to decide what we are doing. Let's just do physics decide, which is always the preferred way. Okay. So we have all the exceptions, and we hopefully have done a good slope detection. So what now? What now? So essentially, we just want to put the character down. That's easy. But there's a catch. We need to find where he would collide with the slope and put him there. How do we calculate that? So we what we can't do is just write a function, put him there. So it's essentially when I click the ground, you see this green slope. And these are the two slopes. And if you put the character here, Unity would automatically detect, okay, there's a collision between those. No, an intersection. It's not a collision. Actually, it's not a collision. It's an intersection of those two colliders. And then it would say, okay, one of two has to go. The ground can't move, so you just move there. Yeah, just put the player out of the ground, and it could give us the illusion that we're doing it right, but we are actually aren't. Just Unity would take control, and I think it would push him out in a 45-degree angle if we are unlucky. So the correct way to do this would be if we would really cast a box down here and say, where does it collide with the slope? I have a different idea. Cast two ways, each from the sides of the box collider, from left and right, and then wherever it is smaller, which way is smaller? So there's a way, just one. This one is double the length, it's 2. Then we pick this way and apply it to the transformed position, put him down there. Works on a slope. Works on a slope. If you look at this surface, we might be casting away here, and we don't detect that there's something sticking out from the start and end of our character. Yay! So this might get complicated. And then again, we could just use an array. From start to end, and maybe do 5 ways. Define how many ways we want to cast, and then just pick the shortest one. I think this is the right way to do, except if there is a Unity function that lets us do this automatically with the box collider. Is there maybe a box function, box detection function? Never heard of that. Like, can we cast this down as a box way? I don't think so. But let's nonetheless just look it up. If I'm wrong, it would be a much better function, especially if it's cost efficient. So let's look at Unity cast box way. Is there box cast? Okay. What does it do? Cast the box along a way and return detailed information on what is it. Center, half extends, this direction already marks this in layer query. Okay, these are the parameters. Okay, there's different parameters for that, but I want to see what it returns. It returns Boolean. That's not good. But it says it returns detailed information. Okay, so out Graycast hit info. Oh yeah, that's where it puts the information. So which one of those two looks less frightening to me? I don't know. Okay. So this is definitely going to be the end of the stream. But let's just say we will continue next time. Let's just say if we're using a lot of functions here. Bool boxway hit is this boxway, was it physics 2D boxway cast boxcast. Okay, we have to look up this in 2D. Looks like it to be different, way different, because it doesn't return a boolean in 2D. Okay, that's actually very, very useful for us. Makes the function just a little bit more easy. So origin, size, angle, vector. Oh, it will be kind of hard to get all these parameters right. So the origin should be this the same as our box collider. But the problem is you could also straight up cast your character's rigid body 2D. I'm not sure if I'm allowed to. Can you do that? Cast a rigid body. Cast rigid body 2D down. Isn't, oh, that's, oh, nice. Okay. That's useful. Because I was just it wouldn't be much of a difference. It's just another cast. But the problem here is I'm actually a little bit too lazy to calculate what kind of box collider we use here. Now, why is it a little bit of a thing for me at all? It's because first we don't use one scale. Scaled him down. I think that means that I can't just read out these values here. I have to calculate them with a scale and things. It has an offset, and it would make it a little bit yeah, a little bit annoying to actually write this. Thank you a lot. Thank you a lot. If this is actually working, it's way more useful. Because this goes around the problem that I have to basically pick the rigid body To re-emulate the box collider again. We already have. Nani? So, how did I set my widget body? I've okay, I have a variable, the widget body, and it just didn't find it. Once that I put in the velocity and set it to 0. Interesting. These suggestions are interesting. No idea. Maybe there's really a stupid AI they've built in and isn't analyzing my voice right now. But that I want to say that AIs are stupid. They are very good in general. What does this return? An integer. What? Do we get something? What do we get out? Results. Oh yeah, we get. Yeah, we need to define the results. Maybe I should have read this before. I actually just want to detect the first thing we hit. So, and I don't have a layer mask. That's also a little bit annoying. Contact to defilter. Maybe I can define a layer mask. What's the difference between this and this? Endcast. Contact filter to D. Results. Distance. Don't see the difference. Direction, filter, results, distance. Direction, filter, results, distance. Am I dumb? What's the difference between those two? Returns integer, returns integer. Okay, I don't see where the difference is between those overloads. Oh, this one is a list. Oh yeah, it can return it as a list. It can return it as an array. Okay, yeah, okay. And so let's define its function, and this will be the end of the stream. Array versus list. Thank you. Thank you. Yeah. That's kind of insignificant. It's just array versus list. And I'm more of a list fan. Actually, I think arrays are more cost efficient. Yeah, or we're doing this per frame, so I actually should use arrays, but I kind of hate arrays. And then, I will have to, for next time, to do look if arrays are way more efficient. And I will have to do that next time. And let's just define this. Oops. Direction, filter mask. Okay, let's also make the filter mask. Contact filter to D. It goes in there. Or we can define the layer mask. Okay. So the only thing that I care about, so I won't read the rest. Contact filter dot layer mask is going to be Wait, why are we even looking for the layer mask? If there's anything else and it's not in the ground layer, so if there's anything else that is not the ground, we should just stop. Okay? So we have to check the results later. We have to check the first result. So let's comment. We will do check the closest targeted. Wait. Will it contact? Will it tell me the contact point? If it doesn't tell me the contact point, it's useless. And I think it will. But let's check that out. That's the wrong one. Waycast hit to D. I think Waycast hit does return the contact point. Yep. It does. Okay, yeah. So when it does that, it should go down here, return this point. We can then check if this is really the ground, if it's an enemy or maybe an object or something, and a projectile that was so small that we didn't detect it before. Then we have to just say, okay, break. Something's there that bandam is. Yeah, something's there that is kind of sus. I don't know. If there's a projectile underneath us, we should still try to be on the slope and then just slope on the projectile. Oh, that's so complicated. Let's say there's an arrow underneath us and it's very small. We should stand on the arrow. Yeah. But if there's an enemy underneath us, we are there. We lack a frame and there's a whole enemy underneath us. And it will be weird, no matter what happens. It will be weird if we are suddenly standing on him, and it will be weird if we are flying above him, because you would expect the character to go there and then collide with the enemy. So, So the correct way would be to emulate that the character has been standing here and goes down there with a complete box cast into that direction. Oof, that's complicated. It's gonna be complicated because if you calculate that wrong by just 1 inch, or if there's anything, if this is not completely flat, it's also going to be complicated. I don't like that. So the problem here is you can easily make a function where it looks like everything is white. The character will go up and down here because we get the contact point. But as soon as we are really playing and something breaks this algorithm, and it will be noticeable. It will not be noticeable in a good way. It will feel completely off. Like really, there's a bug in the game that makes the game unplayable if this is happening at all. And it will be safe at 30 FPS, but if you go down to 15 FPS for whatever reason, too many particles systems, or we are playing on a phone, just can't handle it. Forget it. Yeah. But as I said, to check that next time. It's first continue with this and make this more complicated later. So, so we have the direction is going to be down. Vector 2 down first. Vector 2 down. Oh, vector 21. Why didn't I think of that? Then we have our. We actually don't have a contact filter. Forget about that. Results and what was the third thing? The results and the distance. It should be the same as slope detection length. Actually, this rigid body cast will later be used instead of this raycast hit. Because basically it does the same, just as with a single raycast and less precise. And we have to define those results. Can we just generate that? Oh no, not like that, please. This is a class variable just for this method. Ah, there, okay. It's nice. So, and then we will just go for each. For each result. What is this? Raycast to D. Raycasted to D. Result in results. We have to just typing again. Way too many mistakes there. Yeah, and then we have to kind of remember what is the closest one. Okay, but as said, because of New Year's Eve, today is going to be short, which means thank you for tuning in so far. Has been a really short stream. Thank you, Dino0040, for tuning in and having the first backseat coding since a long time ago. Since backseat programming, since a long time ago. Since most people just ask for tutorials or ask if they should become a Unity developer or something, and usually it can't happen that much. Is quite something different to have somebody actually helping a little bit. Till next time, I see Unity popping up. Thank you. I say until next time, have a happy new year and see you then. Goodbye.